Our next speaker is Sebastian Harl, and he's giving a talk about SysDB, a system management and inventory collection service. Enjoy.
Yeah, welcome to my talk. I'm pleased to see so many people in the morning after the social event who seem to be awake. This is great. As you already said, I'm going to talk about SysDB, which is a project I started around 1.5 years ago, and which main purpose is to collect all kinds of, let's say, inventory information about systems and basically provide like a unified view of all of your infrastructure. A big warning or disclaimer to start with, the project is still pretty new. As I said, it's 1.5 years since my first commit. I'm only doing that in my free time. And I suppose, as most of you know, free time is something which is very rare. So this is still under heavy development. I did plan to have a first release out by today. That didn't quite work out, but maybe I can give another talk about it next year. Anyway, any kinds of flaming, bashing, or other forms of constructive feedback is very appreciated. And I would like to talk to any of you if you have any further ideas about where the project could be going, what features might be interesting, and so forth. All right. First of all, some background or motivation to explain where the project comes from, what gap I'm trying to fill, basically. And yeah. So who uses any kind of monitoring system like using Nagios, that kind of stuff? Good. Who also uses some kind of configuration management system like Puppet, Chef, etc.? Good. Who also uses some kind of performance metric collection service like CollectD, Moonin, that kind of stuff? And who also has some kind of inventory service? Good. Who also maintains a CMDB? Excellent. And who likes their setup? Awesome, you're a lucky guy. Okay, so that is basically the idea. We have a lot of data sources providing information about our systems, and usually they're spread out into many tools, and we don't have a unified view providing like the information from multiple of those backends. To go back one further step, the history leading up to SysDB. Initially, I was thinking about a new web front end for CollectD. Who knows CollectD? Okay, majority. That is nice. So that is a system daemon which collects system metrics. And it's used in very large and mostly heterogeneous environments. And I know of setups that have like a couple 10,000 hosts in their setup. And like the usual front ends that exist so far basically list a long list of all hosts you have in your setup, and that gets kind of complicated even if you only have like a couple hundred hosts. So I was thinking about, I'm using Puppet anyway, and Puppet provides those nice facts which can be used to categorize your systems, and I can add further facts to provide even more details like which data center runs a service and that kind of stuff. So I thought grouping by Puppet facts would be very nice for CollectD, and I could just build a front end that also pulls in those facts from Puppet and then provides like a nice selection, like show me the CPU utilization of all my Postgres servers in some data center, for example. And I thought, oh, when I have that, I could also add monitoring information to that, because that would also be useful. Like, this utilization looks good, but still I have some warnings, so I might have to further dig into what's going on. And I thought, if I go that road, I should make it generic and extensible, so that it can be reused and that other systems could be plugged in as well. And then I realized, actually, I don't really like web development, so I might be the wrong guy for that part. Also, if that is supposed to scale to large setups, then we actually need a good backend, which is then queried by the front end, and basically I need like a real web application and not only a simple web front end. And that is basically where the idea from SysDB comes from. Good. So let's go into what SysDB actually is and what it provides, and also, since it's in a very early stage still, what the future might be. And if there are any questions, please feel free to raise your hands right away and we'll tackle them as we go. Okay, a short overview about SysDB. So the purpose is to collect any kind of information about basically your hardware and your software systems. And the idea is to collect meta information like which systems do I have, what attributes do they have, and that kind of stuff. It's not about providing or storing the actual performance data and the information behind our metadata. And the central idea is that we get one unified view of what all the things we have in our environment and basically kind of have a big, mostly self-populating CMDB-like service. So some simple examples of what is currently going to be stored is host objects and their attributes, and attributes could be facts provided by Puppet, and Chef provides something similar. I don't know what it's called, doesn't matter much. We have services and they also have attributes and that kind of stuff, and we have monitoring information, mostly what kind of monitoring information we have, and since that is fairly simple to actually store because it's just a current state and not a historical thing, we could also actually store the actual state. And SysDB is a service which collects this information and tries to correlate objects coming from various backends. Usually in systems like Puppet, we identify hosts by their FQDN, while in Nagios, we often use some nickname for a host, in a lot of setups I've seen at least. Those are the same hosts, but they have different names. So we need to come up with some mapping to get the name straight and have a canonical name that is then going to be used in SysDB. This is a complicated part if you have really very different naming schemes, but I have some ideas how to tackle that. Okay, some core features. The code is currently available at GitHub. Currently, that is the only web page I have. That is going to be one of the big next steps to actually get more documentation up and running and to have a real website providing useful information. And since this was kind of a playground for me as well, I have to be honest, I was also playing around a bit with how to do unit testing and continuous integration in C. So if anybody's interested in that kind of stuff, it might be worth looking into the code I have. And since GitHub nicely integrates with a service called Travis CI, I'm using that currently. Anyway, so SysDB is written in C, entirely from scratch. It's released under a BSD license, so it's completely free, not, well, at least in my opinion, more free than what GPL usually provides anyway. The idea is that it's easy to extend. So we will have a core which basically manages a data store. We're going to get to that in a minute. And all the information that are going to be pulled in are handled by plugins. So there's not going to be a hard-coded collectd or an Nagios feature built into the daemon, which everybody would have to use. But everybody can select the plugin they are interested in, and also it's easy to integrate custom or even closed source commercial backends as well if you have access to them. It uses a simple network protocol, which is probably going to evolve a bit more, but yeah, that's probably details. And this is something that I consider important for an open source project. And I think every software should be written that way. Most of the code is implemented as a library, so it's easy to integrate or reuse the code in other projects. And I think this is particularly important for this project because it could be very useful to integrate that functionality into existing other solutions. Okay, so I said most of the data collection part is implemented as plugins, and currently only a few of them are available. They are mostly what I'm currently using, which is collectd, which is queried using its Unix socket interface. I have a live status plugin which can query all kinds of monitoring systems which use or expose that live status interface basically. So that is currently Nagios, Niemann, Isinga. There's Typo, Shinken, and those kind of systems. And I'm currently querying Puppet through the store configs interface. This is kind of annoying. This is probably going to change in the near future. Well, not change, but another plugin is going to be available, which is going to collect information from Puppet in a different way. Those are the data collection plugins, and then I also have two, well, let's say utility plugins. One is syslog, which handles logging, as the name suggests, and there's a CNAME DNS plugin, which is a very simple approach for how to canonicalize host names. And basically what it does is it does a reverse DNS lookup and then uses the canonical host name provided from DNS as the name of a host that was pushed into SysDB. All of the current plugins basically do an active poll of the information, so they're running in a main loop, and in a configurable interval they are pulling the information from all the backends. Obviously that is not optimal. It worked fairly well as a first step, but the idea for the future is to also have a passive data collection mode, which will then basically receive information pushed out by other systems. For example, for monitoring systems like Nagios and that kind of stuff, I could imagine using Gearman and the mod Gearman plugin, which can, or is usually used to basically asynchronously execute checks, possibly even on other hosts, and then the check results are reported back to Nagios. And what Gearman also supports is pushing the information to a second service, and it's called dupe server for those who know the configuration. And that could be used to have a Gearman listener in SysDB, which then receives the data from the monitoring systems, and then we don't have to actively poll all the information all the way, but we only get changes when stuff actually changes, or when stuff happened. And of course, I would like to extend it to further systems, and obviously that's the part where you guys come in. I would like a community to build up around the project, obviously, and so it would be nice if there are going to be patches. So this is a very rough overview about how SysDB works. We basically have, well, let's say two parts. It's the core, which is the daemon running on some service and which collects all the information from the other backends. There are a couple of plugins loaded into the process, which then do all the stuff that is necessary to actually get to the information. We have front-end part, which is like basically the interface to a database service, if you want to say it that way, and I have a client. And the central part is the store, and we're going to look at that in a minute. And that is basically doing, well, let's say, most of the work of what like the database feature of SysDB would be. Right, so currently the store is only implemented in memory. Obviously that is not good enough if you want to use it, let's say, as a CMDB kind of replacement. But it's a good first step, and it's fine if you only want to use it to have like basically a caching layer in between your backend systems and some web frontend. For that, it would be good enough. But obviously, that is going to be changed in the future. Yes?
Do you make me happy by storing it as a graph, or is it a relational database?
So the question is if I'm storing it as a graph or a relational database. So currently, it's just some in-memory, basically a graph-structured thing that stores the information. The idea for the future is possibly to also store it in a relational database, like some SQL database or some NoSQL database. That is probably going to be pluggable, and I'm not sure about the details yet. For a relational database, it would be kind of complicated to get the schema right, but those are problems that can be tackled, I guess. So what the store currently does, it stores 3 different kinds of generic objects. And the idea is to keep it as simple as possible, to be able to fit as much stuff into it as possible. So what we currently have is host objects, which basically represent any kind of physical resource. whatever you consider a physical resource. Then we have services, and that is just what you would usually expect from a service. That is mostly some software running on some system, but it could also be something like a virtualization platform which provides a service and then hosts other hosts on top of it. We're going to see an example in a minute. And then I have attributes, and those are basically name-value pairs that store the attributes of hosts and services. The store also takes care of the canonicalization of hosts. So when I basically submit a host to the store, what it first does, it uses all those CNAME plugins, and whatever the result of those callbacks is going to be used as the name that is going to be stored in the store. And a very important detail is that each object, like each single host, each single service, each single attribute has a timestamp of the last update associated with it, and also a automatically calculated update interval. And that is going to be important for future extensions. For example, one would be like having spread out setups, like high availability setups, where I have multiple SysDBs running in parallel, and I can then simply query all of them and see what the latest value is for each single object. And also it will allow us to, for example, detect old hosts, like this host wasn't updated in a month. So either something is wrong in my infrastructure or the host is gone and I should remove it from my backends, that kind of stuff. Also, the store provides an interface to actually query the data, and currently I use JSON as an external data representation. This is probably fairly good for all kinds of dynamic languages, but it has a big drawback in that it only supports very simple data types, which is currently strings, integers, and booleans. And since I heavily depend on information like timestamps, that is, well, not optimal. So I might reconsider that approach. And one thing I had in mind is to use protobufs, because they are very efficient on the one hand. They're supported by a lot of languages, and they're very flexible in how they can be used. But anyway, that is still up for a decision. So here's a simple example of what currently the store could look like in memory, basically. So we start by having a list of hosts. Each host has services assigned to it, and I can have the same service assigned to multiple hosts. Each host and, well, also services have attributes. They're just indicated by those little squares. And this is not currently implemented, but that is the idea for the future, that I can have like arbitrary deep graphs actually of, or well, let's say trees of my infrastructure. So the service could also have child nodes, which are then some other host objects and so on. It's currently not implemented, mostly because I'm not sure yet what like the implications for that be and what the semantics would be. Once that is clear, I'm probably going to implement it. So this is an example, in that case, formatted as a protobuf or similar to that, of what a host looks like. We see that it has the name, those timestamp information, and then basically point us to its child objects, the attributes, and also to go back through the tree, a parent object. A service is basically the same, except that it can have multiple parents. A host by design only can have one parent. So if that is a problem for you, it might make sense to consider some of your hosts as services. But that is something that like actual use of the software will have to solve. And then we have attributes, and they also will look very similar, except that they don't have any child objects. And an attribute obviously also has a value, and the value can currently be any of an integer, floating point number, date, time information, or some arbitrary binary data. Since I'm currently only querying attributes from stuff like Puppet, I'm currently only using strings. Oh, they're missing in that list. So I currently only have string to string key value pairs. Okay, any questions so far? Yep.
choose C for development?
Because I like that most.
Don't you think that might just be because this thing is, in my opinion, clearly targeted to admins and operations?
Yeah.
Usually, in my experience, those people are more familiar with scripting languages, Python, Perl, whatever.
So the suggestion was that C might not be the optimal solution for ops people mostly. Right. So the idea is to also embed stuff like Python into the daemon so that you could write plugins in Python, similar to those familiar with collecd, similar to how it's done there. And also, I guess that a lot of information are going to be pushed in from remote. And so the idea is to have client libraries written in like various languages, which are then able to provide the information. Any other questions? Okay, so going forward, the SysDB client, it's basically an interactive client program for SysDB, similar to what the MySQL program is for MySQL or PSQL is for Postgres. It connects to a daemon, provides an interactive shell in which you can type commands, and it's going to provide the results for you. And it also receives and displays asynchronous log messages related to the current connection from the daemon. This is currently mostly used for debugging purposes. So I'm talking about the query language that I currently implemented. I just see that SysDB query language can be a bad name because that would be very similar to SQL. And the idea is, while it's remotely similar to SQL, it is not SQL. The idea is that it's going to be mostly optimized for doing RPCs. And so most of the information that need to be available for doing query will be some RPC arguments. And so the actual language that you will use in the client is going to be very simple. It will look somewhat similar to SQL, just so that people familiar with SQL won't have to learn like all the stuff from the ground up. But it's important to note that it's not SQL. The current language is still under heavy development. I just finished like the most important commands last weekend, and I noticed a bug yesterday, which I fixed last night. Anyway, currently I support 3 commands, which should be fairly good enough for doing any actual work so far, but obviously that will need some more extension. One is a list command, which will just return a list of all hosts, formatted as JSON. We'll see that in a minute. A fetch command, which can be used to fetch all the details about a host, which means like recursively all the services, attributes, and so on. And I have a lookup command, which is remotely similar to what select does in SQL, but it's very specific to the use case. So currently we can use it to look up host objects, which were according to some attributes. And I'll show you an example in a minute that might make it more clear. Yep, question?
I work with a couple of inventory tools, and what they lack most for me is that they are using the SQL language. Because if you want to know, give me all hosts that are 2 hops away from this host and having this syslog message, then you are totally screwed if you're on a relational database. And if you look at Neo4j, for instance, which has a query language cipher, then you can express this in a very SQL-like way, but you can query this very fancy expressions. And if you have, and I work for a company for Bull that builds supercomputers, we currently have 5,000 hosts, and we're going to have dozens of thousands of hosts. And if you have these questions like, okay, who is the child of the child, and then you will end up burning the server if you use some like the rational database kind of query.
So the comment was that most inventory services that this guy knows use rational databases and basically are limited by what SQL provides. And so having specific queries going into the direction of give me all the hosts 2 hops away from another hosts are not possible because of the limitations of SQL. That is one of the reasons why, while this is similar, I will have very different semantics that will hopefully cover like the use cases required for inventory services. And also, for example, just looking into geo extensions for Postgres, for example, they also provide like totally different semantics than what you usually expect from an SQL database. So it would also be possible to put that functionality into relational databases, I suppose. But yes.
Sorry, if you use the relational database, then it's only lipstick on a pig, I think, because you cannot utilize this query in a reasonable time because it will have, I don't know, and the amount of hops that you want to query, and the query will take years, and if you have a graph database, it takes not years, it takes seconds maybe. So if you have a backend that's a relational database, then
so the comment was about performance of queries doing complex lookups. And yes, as I said, currently I don't have a relational database. I'm not sure yet if I'm going to use that or if that's going to be something different. A graph database might be a very good alternative to something like MySQL or Postgres. That will definitely be a consideration, yes. Okay, so here's a very simple example of what list currently looks like. I guess it's mostly boring. The important part is that it actually does not include any detailed information. It just provides the name, the last update information, and the update interval. And as I said, this is auto-calculated by the interval at which we actually get updates. And if the backend provides a timestamp for when this was last updated, then this timestamp is going to be used. So the information that we'll have in this place is actually going to be the real interval at which the information were updated or changed. And so we actually know when it's actually going to be out of date. Here's a very simple example for what a lookup looks like. So what we do is say, give me all the hosts for which the architecture attribute is AMD64 and which have a service assigned to them which matches the name Postgres. And then I will get a detailed or a list of detailed host information which also includes like all the attributes and service information and the basic information we had already seen before. And I will definitely look into how graph databases work because I really think this is very valuable and important comment about how this should probably work as well. Any questions about that? I guess it's very straightforward. So, talking about some use cases. So, obviously, well, not obviously, but yes, one use case might be to extend or possibly replace your CMDB. Replacing your CMDB is probably not going to happen in most cases because the CMDB obviously also hooks into other systems like financial stuff and that kind of stuff, possibly. And also, the basic idea is similar, but what I could imagine is to have a replacement for a CMDB for like small setups which don't currently have a CMDB at all, so it would actually gain them new information. Or in bigger setups, one could imagine that either SysDB hides the CMDB behind it or the other way around, and we query the systems bidirectional or like in one direction, depending on what makes most sense. And this is why it's very important, in my opinion, to have a SysDB being nicely extensible and integratable into other systems, because that actually makes that kind of stuff possible. So for big setups where you actually have your custom CMDB implementation anyway, it might make sense to hook that into the CMDB. For medium-sized or smaller setups, it might make sense to actually hide your CMDB, which is, according to my experience, in a lot of cases, very badly maintained anyway. And you could actually improve the information in your CMDB by checking it across the information that you get from SysDB. Another important aspect is to base monitoring on top of SysDB. And one simple example for that could be, show me all the hosts or services which are not covered by all backends. And obviously, based on what backends you have, this might make sense or not. It could also mean, give me all the systems that are not currently provided by my monitoring backend, and then I will actually, the monitoring can basically monitor itself by checking if all the important systems are covered by it. Another example could be that I do much more intelligent monitoring by being able to do queries like, what is the global status of all my Windows systems in some data center? So you could probably do that. Currently, you're writing some custom script, which first goes to Puppet, gets a list of all the hosts, and then aggregates the information itself. SysDB will hopefully make it possible to write generic plugins or extensions which could provide that purpose. And, well, yes, obviously, this is where it initially came from, and this is probably what I'm going to be building first, is a more flexible web front end for like all the backends. And one example for that could be to have a dashboard-like system which gives you a rough overview of your infrastructure. You're then able to basically zoom into parts of it or select parts of it based on those attributes or services. Okay, any questions about the current state so far? Good. Then some future directions. The first and most important step is obviously more documentation. I currently have a single man page which documents the command line switches available to SysDB, which is the daemon, and a very short description of what it does. Obviously, there's a lot to do for that, and this is going to be a definite blocker for the first release because I don't want to release something that is not documented. And I think this is especially important for stuff like that that needs to be integrated well into existing systems or combined with existing systems. Yes, possibly some different, well, let's scratch RDBMS in that sentence and make it permanent. I will need some kind of permanent backend for the SysDB store so that information, especially like a host was not updated in a month, if I don't have persistent information, then I will lose that on restart. And obviously then I can't do like the monitoring that I would actually want to base on SysDB. So some sort of permanent backend is going to be available in the future. It might be an RDBMS for simple use cases. It might be a graph database. It might be a custom format. I don't know yet. What is most important that this is also going to be implemented as a plugin, so there will be multiple options that probably can also be combined, and so people can choose whatever suits their use case most. Yes, what I would also like to introduce, as I said in the beginning, the purpose of SysDB is not to store or process performance data or other historic data. It's only about having basically a snapshot of what my system or my infrastructure currently looks like. But it would most obviously be very useful to still be able to access all of that historic information through a unique interface. Like for example, if you have Nagios and PNP for Nagios, which write stuff to ROD files, and you have collectd or Moonin, which populates other sets of ROD files, obviously you can query all of those information from a central location, but I imagine that for each metric identifier that is known to SysDB, it will also know how to query that information and basically provide a unique interface that says, yeah, give me a time series covering this time span for that metric and combine it with some other metrics, and then it will go on and either contact, for example, some graphite in the back end, or it will talk to some local ROD files, or whatever is going to be necessary to get through the data, and then return it to the user. Then I imagine, yes, there's a question.
And also history of the, not of the performance metrics, but host was 4 or 5 years ago, so if you switch the host in a rack or something, so that you have a history of the host.
Okay, so the information was if I considered having a history of the meta information. I did not think about that so far, but I guess that is also a very interesting aspect. And I guess it fits into SysDB, even though it does not actually want to store historic information, but it could be easily done by just keeping old timestamps instead of overriding them. So that could be an optional feature that is available in the future. Right. So what might also make sense is a distributed architecture, and I suppose that is very easy to build. Load balancing is easy because I will just basically split my infrastructure into multiple zones, and I have multiple SysDBs querying information, and then I can put a proxy in front of it, which then talks to all those backends, and so that should be fairly easy. And also high availability should be basically easy because the state for each object is stored in an object, so I don't have to share any state between multiple instances of SysDB. And I can just have multiple SysDBs running in parallel, and I could probably fairly easily manage them through Heartbeat or similar mechanisms. And then also have some basically proxy or front end in front of those multiple instances, which then knows how to query those backends and combine the information and return the result to the user. That is, of course, very simply thought. The details will be much more complicated, but it's not something that I will have in the near future, but it's definitely something that I keep in mind when designing the store and how the data is made available. And actually, one of those front ends that I was just talking about could just be another instance of SysDB, which uses a SysDB backend to query the other backends, and the store will know how to combine multiple objects anyway, because if I get multiple objects for the same host, for example, from multiple backends, the store will have to combine them in some way. And the idea is to make that information that they originally were two separate objects, to keep that information and basically have like a virtual host that then combines those, and that will make it easy to also fix wrong mappings and that kind of stuff. Yes, and obviously I will need some web interface for SysDB because that seems to be the future, and people seem to be less and less willing or able to actually deal with command line interfaces. At least that is the impression that I get. So having a nice interface, for example, similar to what the Logstash interface, I forgot its name, does. Sorry? Kibana, right. I thought that this would be very well optimized for system administrators in general, and it seemed to be highly efficient to me. I didn't use it yet, but something similar to that would be nice. And my ultimate vision for web interfaces in general is to talk to other people developing web interfaces and come up with some way to easily combine those interfaces. I'm not sure yet how that is going to work, but for example, a very simple approach could obviously be to have like a framework which is then able to embed like other interfaces, and which would then make it possible to have people specialized for a product, develop the web front end for that product, but make it easily available to plug that into, well, a bigger service, which then also correlates the information with other systems. So for example, I could have a starting page which like displays information provided by SysDB, and if I basically zoom into the information provided, for example, by Nagios, I could imagine that then I will actually talk to some Nagios-specific web front end, like for example Thruck, which will then provide even more details about the monitoring system. But obviously, that is a very high-aimed goal. I suspect that a lot of developers might not be too happy because they would then be blocked possibly by development of other products, and also they might lose their unique features which would also only be available to them, which I guess I would be very similar to that, might not be what a lot of people like. Anyway, I guess I will talk to people, see what I think about it, and if anybody in this room actually does develop some kind of those interfaces, I would be very happy to get any feedback for that. Yes, and then for like the more distant future, I also envision that the type system and the filtering obviously will need some more improvements, and that also goes into the direction of having more complex queries, like some cross relations between like how my graph of information actually looks like. And also it might make sense to actually support more types in the core, like for example IP addresses, so that I could do queries like give me all the Debian hosts in this IP segment or something like that. And that also shows that JSON might not be the right external representation, because that would, well, it would not make it much harder because we could translate them back, but we would also always have the step between having some binary information that needs to be translated into text representation that is then translated back to a binary representation just to be able to do lookups or that kind of stuff. So that will need some more thoughts, but that can be done, I guess. Also, I'm trying to keep the purpose of SysDB as small as possible, because I think it should be very specialized for basically one use case, and usually if people plan to put too much stuff into one piece of software, it will not work or it will never be done. But for the more distant future, it could make sense to also support other types of information, which are, in my opinion, still very closely related to the infrastructure and like the meta information in my infrastructure, which could be, for example, if we keep it generic, we could basically integrate, well, I'm not going to say address book, but management of persons and groups, which could then be used for ACLs in SysDB itself, and also for stuff like providing monitoring information out of SysDB so that I know who to contact in case of alerts. And yes, I didn't say address book because I don't want to implement a address book in SysDB, obviously, because that would be the wrong purpose. But having the basics, which is having support for persons or people and groups, could make sense. And similar to that, I don't want to integrate support for a full calendar software into SysDB, but it might make sense to be able to actually record and store events. That goes into keeping historical data a bit, but the idea is more to actually like keep important events like change requests, which are very tightly coupled to my infrastructure. And for that purpose, it could actually make a lot of sense to keep like the old state and new state of the system related to a change request in the database. But as I said, that is not for the near future, but for the more distant future. And it also depends on how people are going to use it. And so this is very open for discussion and feedback. Okay. That is it from my side. Are there any further questions, comments, feedbacks, bashing, flaming, or other stuff? Yes?
Sorry, I'm me again.
Well, yeah. I got great feedback. So.
You said web interface, and I think you cannot root out CLI completely because there will be guys that want to script their way with bash and things around. For me, if I think about, and I have to build something similar, I think that's why I have put something.
Should we use some mic? I guess that makes more sense. Yeah. Then I don't have to repeat all of it.
So I was saying that you mentioned web interface and you would like to focus on that. For me, you cannot root out command line interfaces, and therefore I would rather do an API that is clean and that may be RESTful or it's an API, and a command line interface, which is a reference implementation of this API. So maybe you have command line interface, which is a Python script, and which shows the administrator how to use, or how you envision the API to be used. And by providing 5, 6, 7, whatever command line interfaces, the administrator can dig into these scripts and see how clean and well thought your API is, and then he can create his own scripts pretty much out of the box. And I think this will be my hope for
Absolutely. So I'm
this.
definitely not going to scratch the command line interface or any other form of automated interface. And as I said earlier, one of my main goals is actually to make it possible to use the network protocol that is currently used by the client and the database, to optimize that for reuse in RPC calls. And that is actually going to be the idea, that we will basically have a core implementation of that protocol, which is then going to be used by the client, which is currently written in C, which is like that command line interface, which can be used for debugging and easily looking up information. And it's also going to be used possibly through another layer of abstraction for a web front end or some web API.
Yeah, but like I don't remember the name. He said that he likes, or he thinks that Python is a good scripting language, and I think that's the same. If you implement the command line interface in C, then it's not. Then you have to parse the output and put standard in if you want to change things.
Yeah.
I rather think that, as I said, API and then clean reference implementation in a Python code, or
I guess that makes sense. So currently I implement it in C because like all of my utility functions are written in C.
I don't know
but
C. So
once I have a good client library, which is also already in development, it's probably going to be very easy to provide a Python wrapper around that. And then it might actually make a lot of sense to rewrite the client in Python, because for the client it's, well, performance is not that much of an issue compared to the backend. And that is also one of the reasons why I wanted C for the backend, because that should be performing very well, and I hope to get that by using C.
yeah, and please keep it simple and not use CFFI or stuff. I have to use CFFI using Python or using C code and C libraries in Python, and then I'm forced to use CFFI. And I think that's
What is CFFI?
CFFI is it's a you can use C libraries, creating C types in Python by loading a C library, and then I don't know C much, so I have to use it, and it's like you provide a C library and you can use it within Python by reading the headers and the libraries from the C function.
You're saying that approach sucks.
It's painful.
So yes, I can imagine.
If you're a Python developer and you want to use Python, and then you have to use C types, and you have to have an integer.
Right.
And
so I will probably use like the core protocol client stuff in Python, but I'm not just going to auto-generate some Python library around that, because then I would have C code that looks like Python. So I will build a Pythonic interface on top of like the low-level stuff that is going to be used from C, but I'm not going to re-implement all the core talking to the daemon stuff in Python, because that doesn't make sense.
Fair enough. Okay, thanks.
So as I understood, your intention is to depend on other systems feeding information into SysDB. You're not actively collecting from somewhere, or?
So currently I'm actively collecting.
Oh, you are actively, okay.
And the idea is to also provide a way to get the information passively, so using some push mechanism from the other systems.
And do you intend to just implement maybe some simple network scanning thingy there just to detect what is out there, or is that,
no.
Some inventory systems do that?
Right, so there are inventory systems that do provide that feature. So I think it doesn't make sense to re-implement that, but rather to have those inventory systems talk to SysDB and provide their information to SysDB so that I can aggregate them again and have this single unified view. And talking about the polling mechanism again, I was also thinking about having, well, a query parameter probably that says, if I query now, don't use like the information that you currently have in the store, but actually do query all the backends you know right now and get me the most up-to-date information. So that could also be used if, like, if I query only very infrequently and I mostly want to use this aggregation feature, then I could say I will have polling backends, but they're disabled by default, like they don't regularly update the store, but they will also they will only call out to the backends when an actual query comes in from the outside, like from the SysDB outside. And the idea is to have all those options available and hopefully in a flexible and still easy to understand way that you could use whatever suits your purpose most. Any other questions in the back?
Is there a rough timeline or a roadmap?
Not yet. So I consider that part of documentation that is currently still missing. But yeah, the idea was to have a first release out by now. That didn't work out. I'm hoping to have a first release out soonish, and that will also include information about the current state, next steps, and I will probably use the GitHub issue tracker for feature requests and probably also for like a roadmap or to define milestones.
I was just thinking, SysDB is the only approach, or you know about other projects doing similar things?
So I'm not aware of any systems going into that direction, else I would have probably not started SysDB. I think this is currently a gap that is not really filled by other systems. You could maybe reuse systems like Logstash and Reman and those kind of things, because they have like at least slightly related approaches. They're also aggregating information from all kinds of systems, but their focus is more on actually having well, correlating graphs more or less, or let's say time series data.
I like the idea very much, but I feel I have to wait 2 more years until it gets usable.
Probably, yeah. So if anybody knows a similar project, please talk to me as well, and I might just scratch SysDB altogether if there's a good replacement or a ready-to-use alternative. But as I've said, I'm not aware of any. Okay, if there are no further questions, as I said, currently the code is on GitHub. Please feel free to send patches, and patches can also be open issues and request features or provide feedback, and if that is valuable. And of course, actual code patches are, well, not more welcome, but more targeting to a goal of getting it ready quickly, obviously, because as I said, my spare time is limited, and yeah. Thank you for your attention and have a nice day.